This is my job, heavy transport. This time we need to transfer this over 300-ton transformer to Shuitu, Chongqing. For this task, we brought several truckloads of equipment and worked and lived in Chongqing for 10 days. To ease the journey, the vehicle is split before reaching the loading point to avoid wasting traffic resources. During the journey, iron chains lock the diagonal beams tightly to prevent them from swinging back and forth like wings. Even when empty, the escort vehicle must remain vigilant. When the lead vehicle needs to turn or change lanes, the escort vehicle must early control the curve. The transformer we are transporting is manufactured by Hitachi Energy. It possesses world-class transformer design and manufacturing technology, with various facilities and equipment neatly arranged within the factory area. Each set of equipment is labeled with identification information, and everything is meticulously organized, giving an impression of extreme standardization. In one area, there are numerous transformers waiting to be shipped out, and the one we are transporting is the largest currently in production. We will use a 4-row hydraulic flatbed trailer to move the transformer out of the factory area and then transfer it onto the red bridge beam transport vehicle to carry it. This is an extremely complex process. After arriving at the worksite at 5 p.m., the workers packed up their belongings and headed to temporary accommodations, preparing for 10 days of intense work starting the next day. I like this kind of team. The work is powerful and passionate. As long as there is mutual respect, you can gain friendships among men that are simple and pure. One group of people enters the site to install the transformer at this location, while another group assembles the bridge-type transport vehicle outside the site. To better distribute the weight, the middle-colored section needs to be spliced into the transport sequence. Before that, the parts on the tower and the vehicle board need to be separated. This iron piece is the fulcrum for the tower's load bearing, and it needs to be installed in multiple directions because the components are extremely heavy. Assembling the iron parts is hard work. Set up the fulcrum and prepare to lower the hydraulic vehicle board to separate the tower from the vehicle board. After the base bears the weight, remove the hydraulic vehicle board and prepare to add the assembly hydraulic vehicle board module. The crane needs to be repositioned to assemble the module. Now you can clearly see the condition of the vehicle board tires. This is just the added 4-axle module. Once assembly is complete, it will be a 16-axle line. Precisely align the connecting mechanisms on both sides and lock them with this small pin. If it doesn't fit in, it indicates a deviation, and the side panel position needs further adjustment. Tighten the connecting screws on top and connect the hydraulic lines, which completes the assembly. To transport the transformer, use a jack to lift the transformer, adding layers of sleepers to level it with the hydraulic vehicle board height. Once the transformer is lifted into position, tidy up the sleepers and hydraulic lines, and move the hydraulic vehicle board into the designated position to prepare for pushing the transformer. Due to the relatively narrow roads in the factory area, we use a 4 longitudinal split hydraulic flatbed truck to load the transformer and transfer it outside the site, then use a bridge beam transport vehicle for long-distance transportation. After multiple precise adjustments, the vehicle board is aligned parallel to the transformer, and the laying of the steel rails begins. Due to such constraints this time, we are using lightweight steel rails, which are easy to carry and assemble. Since the sliding coefficient between iron and iron is relatively high, rubber pads need to be laid on the rail path. This pile consists of components for splicing and locking the steel rails. First, introduce a sufficiently long steel rail to the bottom of the transformer and adjust its position. Then, use fasteners to lock the rail connections. While installing the fasteners, apply enough grease to the rails. After using the electric wrench, the nuts still need to be manually tightened. Installation is complete, lower the transformer and begin the push. The push still uses a jacking device. This area is full of transformers. If I work hard enough, I might be able to afford half of one. Inside the site, the pushing of the transformer and the assembly of the bridge beam transport vehicle outside are carried out at once. Switching the transport vehicle from an empty driving state to a transport state requires installing tie rods to form a fixed frame with the inclined beams. Once the transformer is pushed into position, the impact meter on top of the transformer is checked again. This is the instrument used by the manufacturer to monitor the impact factor on the transformer. If it experiences an impact during transport, it exceeds the safety range. If it exceeds the safety range, the transport task fails, and the transformer completes its final factory work in the workshop. We press the transformer to the designated loading position. Of course, the selected operators are not allowed to consume alcohol. Before leaving the factory, the transformer must adhere to strict securing standards, with dense securing points, making the iron chains resemble a spider web. At 10 o'clock, a 4-row hydraulic flatbed truck carries the transformer out of Hitachi Energy to the designated transfer location, which is actually just outside the Hitachi Energy perimeter wall. However, due to site limitations, it can only be transferred to a short flatbed outside the site, and then reloaded onto a long flatbed for transportation. The transfer point has already been prepared with sleepers in advance. After stopping the transformer at the designated position, we just wait for tomorrow to move and load it. Today we will use the same method to push the transformer back onto the sleepers. After the decommissioning is completed, the 4-column hydraulic plates are removed and prepared for assembly. The 4-column TARC gate of Chaoxiliang needs to be disassembled and transported to the destination in advance. Once assembled, it waits for the convoy to arrive at the power plant to continue loading the transformer into the receiving point. The truck head merges with the bridge beam transporter and moves into the assembly position. After the tow bar is connected, the air pipes are connected to synchronize the braking system of the tractor with the hydraulic flatbed behind. The hydraulic plate operator, Tang Yong, has already taken his seat. That's my favorite open-top throne. The front and rear diagonal beams are precisely inserted into the assembly position. Even a slight deviation when positioning can directly lead to difficulties in assembling the main beam later. After confirming from multiple angles with a tape measure, begin the docking process. Once one end of the main beam is assembled, the diagonal beam at the other end is inserted into position. Once both ends are in place, insert the pins to lock them. This encloses the equipment within. The final step in lifting the equipment is to set up blocks for each shoulder carrying point. Raise the hydraulic cart plate and use the main beams on both sides to lift the transformer. During the lifting process, closely monitor the entire framework to prevent issues from sudden force application. After multiple attempts, the transformer was successfully lifted. Once the transformer is off the ground, remove the sleepers and tidy up accompanying equipment. The convoy is about to set off, so everyone, please get on board quickly. Less than 500 meters after departure, we encountered trouble. Several small cars blocked our route, and even though safety cones were set up in advance, it didn't stop them from wanting to park. The commander contacted the car owners, who said they would arrive in 10 minutes to move the cars. We waited from day to night, and finally, we had to resort to the method I least wanted to see. Using a forklift to lift the chassis, raising the tires off the ground. We pulled this one. The forklift moved the small car to a place where it wouldn't obstruct traffic and was safe. We continued to advance. Today's journey was very short, just to avoid the traffic peak, so we chose to travel at night to the highway toll station, making it convenient to get on the highway directly tomorrow. This intersection is the biggest challenge today. The driver is coming from the right intersection and needs to turn into the upper intersection. Due to the tight curve, we need to go straight to the left, choose the right angle, and reverse into the lower intersection. At this point, the rear push head has been removed and steering is entirely done by manually adjusting the tire angle. The difficulty lies in reaching the limit at both positions simultaneously. After multiple attempts, we finally found the perfect route, where the hydraulic plate and the side main beam pass the obstacle at the limit distance. The vehicle unit is aligned and proceeds along the predetermined route. Once aligned, the tractor is connected, restoring the driving state. Afterward, the tractor also needs to connect to the hydraulic car plate's automatic system. Once connected, it continues to advance towards the highway toll station. In complex road conditions, the supervisors need to closely observe the vehicle unit's operating status, and walking alongside the vehicle for 10 kilometers is a common occurrence. The vehicle unit reached the Jimu toll station entrance close to midnight. After setting up warning signs and unloading the transformer, it marked the end of a particularly long day, starting from 6 a.m. to reach the transfer point and arriving at the parking spot by nearly midnight. From the Jiemu toll station to the Shuitu toll station on the highway, it's only 34 kilometers, which can be reached in half a day. Before getting on the highway, we checked the paperwork for each vehicle. The toll station had been dismantled, and both sides of the guardrail were spacious, so passing through was smooth. The ramp had a large enough curve, so we didn't have to go through the trouble of driving against traffic to get on the highway. After getting on the highway, law enforcement was controlling the traffic flow behind us, so we only needed to focus on the driving status and passage of the vehicle owners, and everything became smooth. When crossing bridges to reduce the load on the bridge structure, large electric vehicles and other vehicles are not allowed on the bridge at the same time, keeping the traffic flow outside the bridge. This gave us a deep appreciation of Chongqing's reputation as a mountain city. In just 37 kilometers, we crossed 27 bridges and 3 tunnels. The convoy headed towards the ramp, and we could already see the distant destination of the Huaneng gas power plant. From the Shuitu toll station, we drove the wrong way down the highway, with the left side's guardrail already removed, allowing us to pass closely along the shoulder. If the route survey team couldn't pass, we might have had to drive through the night. After the operation, it was changed to Shanxing personnel for supervision, and we asked the following vehicles to give way in advance. Thanks to the cooperation of our friends in Chongqing, we continued to advance towards the power plant. After many complicated operations on the 4th day, we finally arrived at the Huaneng Chongqing Liangjiang gas turbine power plant project with an annual power generation capacity of approximately